In the field of agricultural machinery, work efficiency has become a top priority. Efficiency can be enhanced through easier machine operation, such as by using an HST or hydrostatic transmission, which dramatically improves ease of operation by enabling an operator to change from forward to reverse and to change speeds using just a single lever or pedal with no need to operate a clutch. In this video, we will explain the basic structure and function as well as the flow of hydraulic oil in a Kubota HST. First, let's look at the basic structure and function of an HST, which is comprised of a variable displacement pump and a fixed displacement motor. The pump and motor are both housed in the HST unit block. A power source, in this case the engine, drives the pump in the HST. The pump and motor in the HST are basically connected through just two oil passages. The pressure of the hydraulic oil sent to the motor by the pump makes the motor rotate. As a result, the wheel connected to the motor also rotates, transmitting the engine's power to the machine to be driven. Let's look at the relationship between the engine and the HST and the transmission and speed change lever. This is a cross-sectional drawing of a Kubota combine harvester. First, the engine is started. A belt drive connected to the engine makes the HST input shaft rotate. As a result, the pump in the HST starts operating. The speed change lever of the machine is presently in the neutral position, so none of the gears in the transmission move. When the speed change lever is moved to the forward position, the HST output shaft begins to turn. The gears in the transmission also begin to turn, transmitting power to the final axle. As a result, the motor in the HST begins to operate. When the speed change lever is returned to the neutral position, all of the gears in the transmission stop. Next, when the speed change lever is moved to the reverse position, the HST output shaft begins to turn in the opposite direction. The gears in the transmission also begin to turn in the opposite direction. As a result of this rotation, the final axle also turns in the opposite direction. Let's now look at a cutaway model to more closely examine each part of the HST and its function. As explained before, this is the input shaft, which turns continuously when the engine is running. This is the trochoid-type charge pump. The charge pump is driven by the rotating input shaft. Hydraulic oil is sucked into the charge pump through a filter in the hydraulic oil tank. The charge pump then supplies the oil to the hydraulic circuit in the HST. The interior of the HST housing is always filled with oil. The hydraulic oil forcefully fed by the charge pump enters the oil filter, and clean hydraulic oil, which has passed through the filter element, is supplied to the hydraulic circuit and the HST housing. This is the charge relief valve. When the hydraulic oil fed by the charge pump is supplied to the oil circuit and HST housing, surplus oil is normally generated. The pressure of the excess hydraulic oil opens the charge relief valve, returning the surplus oil to the HST housing. The hydraulic oil which passes by the charge relief valve enters the oil circuit. The hydraulic oil filling pressure can be set using the charge relief valve. Now let's look at the pump mechanism. Here on the pump side is what we call the cylinder block. The input shaft and the cylinder block are connected by a spline, so if the input shaft turns, the cylinder block also rotates. In the cylinder block, an odd number of pistons are arranged to reduce the discharge pulsation of the hydraulic oil. This HST has 9 pistons. By operating the speed change lever or pedal, the machine can be moved forward or reverse. Moving the speed change lever forces a variable swash plate to move on the HST pump side. Here you can see the variable swash plate as it moves. Located between the variable swash plate and the pistons is a thrust plate, over which the pistons move and slide. This part of the piston, called the piston shoe, moves freely. The inside of the piston is hollow, and hydraulic oil enters it from the back. The hollow part of the piston is connected to a small hole in the center of the piston shoe. A small amount of hydraulic oil leaks from the small hole in the center of the piston shoe, functioning as a static bearing and also as a lubricant. It serves to reduce the bearing load and allows the piston shoe to slide smoothly on the thrust plate. The pump always rotates in only one direction, as it is directly driven by the engine. Please remember that the cylinder block and pistons are always filled with hydraulic oil. Here, the variable swash plate is in a vertical position. Now please pay attention to the cutaway part of the cylinder block and watch the movement of the pistons. As you can see, all the pistons remain in the same position, with the result that there is no pumping action. Next, let's incline the variable swash plate and turn the input shaft. You can now see that each piston in each hole of the cylinder block reciprocates because of the inclination of the variable swash plate, establishing a BDC, or bottom dead center, and TDC, or top dead center. When each piston moves from the BDC to the TDC, hydraulic oil is pushed out of the back of the piston. This results in a pumping action. At the same time, on the other side of the cylinder block, the pistons are moving from the TDC to the BDC to generate a sucking action. Now let's incline the variable swash plate in the opposite direction. The input shaft always rotates in the same direction because it is directly driven by the engine. The positions of the BDC and TDC have now been reversed, and the pistons seen here are creating a sucking action. Of course, on the other side of the cylinder block, the pistons are moving from the BDC to the TDC, generating a pumping action. Next, let's see where the hydraulic oil, which is pushed out, goes. Here you see the motor side. The parts, such as the cylinder block and pistons, are almost the same as for the pump. The cover of the HST housing is called the center section. It contains valve plates for both the pump side and the motor side. The two valve plates differ a little in shape. When disassembling and assembling the HST, it is important that they are correctly reattached. Each valve plate is fixed in position with a pin in the center section so that they do not turn. Each valve plate comes into contact with the rear end of the cylinder block. Because the cylinder block rotates, it rotates on the valve plate. The high-pressure hydraulic oil, pushed out by the pistons, enters the center section through the valve plate. Lubrication is necessary between the cylinder block and the valve plate. Too much hydraulic oil should not leak in order to maintain high transmission efficiency, but a little leakage is necessary as a lubricant. Next, in the center section are holes called kidney holes, 2 on the pump side and 2 on the motor side. Let's see how the 4 kidney holes are connected by looking at a cutaway model. As you can see, one of the kidney holes on the pump side is connected to one of the kidney holes on the motor side through an oil passage in the center section. The kidney holes on the other side are connected in the same way. Here you can see what is called the check and high pressure relief valve. There are 2 of them, one for each oil passage. We will explain how they function later. Next, let's look at the structure of the motor. First, as you can see, a fixed inclined plate with a unique shape is installed on the motor side inside the HST housing. It is called a fixed swash plate. On this fixed swash plate, there is a thrust plate. The piston shoes freely move and slide on the thrust plate. Let's see how the motor mechanism works. High-pressure hydraulic oil from the pump enters a kidney hole in the center section and travels through the oil passage in the center section to the motor side kidney hole. The high-pressure hydraulic oil that comes out of the motor side kidney hole passes through the valve plate and enters the hole in the cylinder block, pushing all the pistons in front of the kidney hole from the rear. Let's see why the output shaft turns when the hydraulic oil pushes the motor pistons from the rear. As you can see, when the piston is pushed from the rear, it moves downward toward the fixed swash plate. Each piston moves in this way, one after the other, as it passes in front of the motor side kidney hole, creating a smooth motion. The sliding pistons force the motor cylinder block to move. And because the cylinder block is connected to the output shaft by a spline, this causes the output shaft to turn. Now let's briefly review the relationship between the pump and the motor mechanism. When the variable swash plate in the pump is in a vertical position, no hydraulic oil is pushed out by the pump. Then, when the speed change lever is moved in one direction, hydraulic oil is pushed out through tube A, and tube B performs suction. The high-pressure hydraulic oil enters the motor. The motor pistons are pushed onto the thrust plate on the fixed swash plate, and the output shaft starts turning. Moving the speed change lever to the opposite side inclines the variable swash plate in the opposite direction. The hydraulic oil is now pushed through tube B and enters the motor's opposite side, turning the output shaft in the reverse direction. The distance the pump pistons move in the cylinder block, and thus the volume of oil pushed out, is controlled by the angle of the variable swash plate. This means that the machine speed changes depending on the angle of the variable swash plate, Increasing the inclination increases the machine speed, while reducing the inclination reduces the machine speed. Thus, using just the speed change lever to control the inclination of the HST swash plate, an operator can control the output shaft speed and rotational direction and move the machine forward or backward at a selected speed. Now we'll explain about the proper hydraulic oil to use in the Kubota HST. To properly maintain a machine equipped with the Kubota HST in optimal operating condition as long as possible, Kubota recommends that customers use only genuine Kubota Super UDT or UDT oil, or the recommended oils shown here. Finally, let's see how hydraulic oil flows inside the HST. The main components for operating the HST are the hydraulic oil tank, the HST unit itself, the oil filter, and the oil cooler, as well as external parts such as the engine and speed change lever. First, the engine is started while keeping the speed change lever in the neutral position. At this time, there is no flow of hydraulic oil from the pump to the motor, even though the pump input shaft is turned by the engine, because the variable swash plate is in a vertical position, so the motor remains stopped. When the input shaft turns, it also forces the charge pump to rotate. When the charge pump is operating, oil in the hydraulic oil tank is sucked into the charge pump through the filter in the tank. The oil discharged from the charge pump flows to the charge relief valve, and then to the check and high pressure relief valve, after passing through the hydraulic oil filter. The check valve spring of the check and high pressure relief valve is weaker than that of the charge relief valve, so the oil depresses the check valve spring and enters the oil circuit that connects the kidney hole on the pump side to the kidney hole on the motor side. The oil that enters the oil circuit flows into the pump and then into the motor, leaks through the lubricating parts of the pump and motor, and finally enters the HST housing, where it returns to the hydraulic oil tank through the oil cooler. Surplus oil from the charge pump depresses the charge relief valve, so it is always slightly open while the engine is running, and is also returned to the hydraulic oil tank. The HST is always operated with the oil at a high pressure, so the oil tends to heat up. This means it is necessary to cool the oil to maintain its lubricating properties and the oil film effect. The oil cooler is normally located beside the engine's radiator, so it is simultaneously cooled by the engine's cooling fan. Next, let's move the speed change lever to the forward position. Inclination of the speed change lever also inclines the variable swash plate, starting the action of the oil pump. The high-pressure oil from the pump enters the motor and depresses the motor pistons from the rear. As a result, the motor output shaft begins to rotate. At the same time, the high-pressure oil presses the check and high-pressure relief valve from the rear, closing the check valve seat so that high pressure is maintained in the forward oil circuit. The oil from the charge pump depresses the check and high pressure valve on the low pressure side to replenish the oil and prevent a shortage. Surplus hydraulic oil from the charge pump returns to the hydraulic oil tank through the charge relief valve. The oil pressure in the high pressure circuit changes according to the output shaft torque. This means, for instance, that when climbing a slope at low speed, the oil pressure in the high pressure circuit will become higher compared to when traveling at the same speed on a flat or downward slope. When traveling on bad road conditions, the oil pressure is constantly changing. For explanation purposes, let's think that the machine is running smoothly with no obstacles. Now let's move the speed change lever a little toward the neutral position. the volume of oil pushed by the pump through the high-pressure circuit is reduced, and as a result, the motor output shaft turns more slowly. Let's move the speed change lever a little more in the same direction. The motor output shaft turns even more slowly. Finally, let's put the speed change lever in neutral. As you can see, the motor output shaft is stopped, and both of the check valve seats are open again. Next, let's move the speed change lever to the reverse position. Inclination of the speed change lever also affects the inclination of the variable swash plate, changing the position of the pistons and starting the action of the oil pump. Compared to when the lever is in the forward position, oil from the pump enters the motor from the opposite side and pushes the motor pistons from the rear, so that the motor output shaft turns in the opposite direction. The high-pressure oil closes the check valve seat by pushing from the rear of the check and high-pressure relief valve in order to maintain high pressure in the oil circuit. Now let's suppose that the traveling part of the machine locks up due to an external factor and stops rotating. At that time, the pressure in the oil circuit reaches its maximum value, but the pistons on the motor side can't move. With the speed change lever still in the same position, the pistons on the pump side continue receiving power from the engine and continue pumping oil. Finally, the powerful spring of the check and high-pressure relief valve is depressed by the overwhelmingly high internal oil pressure. The poppet moves to the left, and high-pressure oil spurts out to the left, preventing damage to the HST. When the high-pressure relief valve opens, the output shaft on the motor side stops rotating. We hope that this video has provided you with a thorough understanding of the structure, function, and hydraulic oil flow inside a Kubota HST, which combines a variable displacement pump with a fixed displacement motor. Thanks to its tremendous ease of use, the HST is helping to revolutionize modern agricultural machinery.